Hi guys, all of you good morning. Guys, today today we are going to starting Docker. Okay? Docker or Dockerization or containerization. Okay? Containerization we are we are working with Docker. We are working with Docker. Inside the Docker or the Docker works like as a containerization software or tool or containerization tasks. So what is a container? What is a container? Container nothing but a instance, virtual instance, virtual instance. Same like that. How we are going to creating a EC2 instance? How we are going to creating a Azure? Okay, VM. How we are going to creating a VM in the VMware? Okay, virtualization. Okay, virtualization mission VM. But compared to Docker and this virtualization, so virtualization is the heavyweight technology. Docker is the lightweight technology. Docker is the lightweight technology. Whenever you are going to creating a VM in VMware or any virtual box or a hypervisor or a Hyper-V, these technologies, or these tools should have proper requirements. Okay, the requirements: RAM, processor, disk space, okay, networking adapters and all. But whenever you are going to creating VMs in the virtual box or in the VMware, those VMs should have that RAM and processor. Depends on our physical RAM, depends on our physical RAM and physical processor and physical disk. Those VMs depends on physical RAM and physical processor. Physical RAM and processor mean, see guys, just wait, see guys, this is my physical RAM and this is my physical processor. This is my another laptop, this is my another laptop. Okay, see, on these resources only we can create VMs. Okay, within these hardware resources you have to create the VMs, either single VM or multiple VMs. Okay, more than this, more than these resources you can't create VMs. Okay, whenever you want to create more than these resources you have to buy another lap or desktop or any other servers and all. That's very difficult. Okay, very expensive, very expensive. Even if you want to configure that environment, physical environment, maybe it will take couple of hours or couple of days. Complete end-to-end configuration, networking, power cables and software, so physical server placing in the rack, mounting. Okay, it will take couple of hours or couple of days. Okay, that heavy expensive, heavy expensive. You have to invest money on both sides. You have to invest at manpower side and you have to invest money on resources. I mean that these hardware resources you have to invest and you have to buy the licenses and all also. It's very difficult. Okay, if you want to overcome by this virtualization technology, you can't overcome. You have to invest. By by over how you can overcome these issues? You have to invest money, you have to set up environment. Without spending money or without investing money you can't overcome these problems. Okay, these are the major challenges here. But but by this Dockerization technology, we can overcome these problems. On one single high-end physical server, we can configure n number of VMs within the minute. We can destroy, we can configure network, and we can install the softwares. Within 1 minute, we can set up. See, where is 1 minute and where is 1 hour? You can compare. If you want to configure physical environment, it will take couple of hours or couple of days. But coming to this virtualization, containerization technology, if you have that Docker software, yes, we can finish within 1 minute. We can create 10 to 15 servers or 20 servers within 1 minute. We can create containers. Container nothing but a instance. Instance nothing but a VM. Okay, you got it now? See guys, now this is my hardware resources. On this hardware resource, now I am going to installing a Docker. Okay, first of all, let me show you that Docker installation and how it works the Docker. Then we will go for once again some more with a theoretical. You can understand that. I'll show some diagrams. Okay, the Docker architecture and virtualization architecture. I'll show you that. You can understand a little bit easily. So first of all, uh, learn a little bit that what is that practical commands, what is a container, how it works, how much it will take time to create, how you can execute commands inside the container, okay, how you can destroy or how you can restart, how you can close, I mean that how you can shut down. Okay, so first of all, you have to learn these concepts, then you can understand little bit easily about this Docker. But guys, keep in mind, maybe it will give you confusion, you will be in confusion. Okay, next 1 to 2 classes. Okay, so if you do some practicals hands on, then understand, you can understand easily. First of all, you need to digest some things here, because already you saw that VMware and whatever you saw that laptop or desktop or something like that, EC2 instance or something. Okay, but not like this here. Okay, it's complete command oriented, it's complete commands. If you want to work with Docker, you have to learn Docker related commands for creating a container. Container nothing but instance. Keep in mind, it's a strong word. Okay, container nothing but a instance, or VM, virtual VM. Okay, but compared to VMware VM, compared to Docker VM, Docker VM is the very lightweight VM, and coming to VMware VM, that's a heavyweight VM. Heavyweight VM. Okay, whatever you have given the resources for VMware VM, you can work with only one VM. Whatever you have given the resources for one VM in the VMware, with the same resources, we can create multiple VMs, multiple servers in the Docker. Okay, with the same resources, we can create n number of servers or instances. In the Docker terminology, it's calling as a container. Keep in mind, whenever you are inside the Docker, always you need to call as a container to instance. Okay, every container creation, image pulling, image deleting, container restarting, removing. Okay, everyone should work with commands only, like like git, or else like how we are working with the Linux commands, like that you have to execute line what is that Docker commands. But keep in mind, already you are having some knowledge and experience working with Git. Whenever we are inside the Git, always we are calling the first word, the first command Git. Then only we are giving attributes. Attributes nothing but behavior. So whatever you want to execute the commands with a Git, first you are going to writing Git, then we are going to writing commands. For example, Git clone, Git version, Git add, Git commit, Git push, like this. Okay. Here also first you need to write the first command git, sorry, docker. That docker command also should maintain case sense. I mean that complete lowercase. Complete lowercase. Okay. You have to follow the case sense. The docker command works on lowercase. Okay, guys. Now, first of all, let me show you how to install Docker on our local Linux machine. Here, guys, keep in mind we can install on Windows also. Okay, you can install Docker on Windows machine also. But keep in mind, it's very hard. If you have installed Docker, imagine it. Already we have installed VMware on our Windows machine. Okay. After installing VMware, if you are going to installing Docker, your VMware won't work. Okay. You got it now? It works on Docker. You can work with Docker, but you can't work with VMware. You have to remove Docker. If you want to work with VMware, you have to remove Docker. Okay. Both are virtualization technologies. Docker also virtualization technology, VMware also virtualization technology. But compared to VMware, Docker is lightweight technology. Okay, the configurations, settings and configurations goes to Docker side. Whatever we have given configurations and settings on VMware, this all settings moves to Docker side. You will get some issues. Sometimes you can't work with both also. So keep in mind, whoever have installed VMware on their Windows machine, don't try to install Docker on Windows machine. You got it now, guys? Don't try to install Docker on where you have installed VMware. Okay, on both OS you can't. Okay, you can't work with both. Okay, just use the VMware and create the VMware. Sorry, install the VMware and create one VM, either Windows or Linux. You can create VM, then you can install Docker on that VM. Okay, now you can work with VMware and you can work with Docker also. Whenever you don't want to work with Docker, just shut down the VM and you can work with VMware. Okay, guys. Whenever you want to work with both, just power on the VMware and launch the VM and work with Docker. You got it now, guys? Now, let me show you how to install Docker on our Linux machine. See, guys, this is my Linux machine. Okay, I'm using cat space /etc Red Hat ROS-release. Okay, guys, I'm using Alma Linux 9.4. I'm using Alma Linux 9.4. Okay, now the command mlist docker -ce. Guys, we are going to installing Docker CE version. Now we are requesting to Alma Linux repositories. See, we got that message, no matching packages to list. So it's mean this Docker software is not available in the Alma Linux repositories. This Docker software is not available in the Alma Linux repositories. Okay, it is somewhere else. So I mean, just wait, guys. Just wait. Yes, ma'am.
Yes, sir.
Okay, guys. So what we are discussing? Yes. Yes. What we are discussing? Tell me. Docker. instance. Okay, Docker instance. Okay, so first of all, I got that issue. Just let me first of all install that. First of all, let me install that Docker here. Okay, why we are seeing this message? See, guys, here we don't have that Docker community software here. So what is the reason for saying? See, guys, this is our local machine. I mean our local laptop, local machine. So inside this machine, we haven't installed Docker. We haven't installed Docker. So what is the command to know the package is either installed or not? RPM space hyphen QI hyphen Docker CE. We are using Docker Community Edition. See, package Docker CE is not installed. Even we are listing from the M list Docker hyphen CE. See, no matching. Okay, no matching packages to list. It's mean. So from where we are getting this message? From where we are getting this message here? So guys, this is our local mission. This is the Alma Linux package repository. Alma Linux package repo, remote repo. So whatever we are going to executing the command rp or mlist docker ce hyphen I. This command going to this repository. It is also server. The server, inside the server, they are maintaining all installable packages. So out of this, inside this repository, there are different packages. There are different packages. So out of those packages, whatever we are searching, the package is not available here. The package is not available. Okay, it's saying that no matching packages list. See, here from the local mission, we are asking that give me Docker software, give me or list me Docker software, Docker CE software in this server. Now we got the message from here. We got the message from the mrepo list or Alma mrepo list server. See, no matching packages are not found or not listing. So if you want to install Docker, here's what you have to do. See, guys, this is the Docker Hub organization or Docker organization. This is the Docker organization. Here they are providing Docker software. They are providing Docker software. So we need to download and install from this mission. From this repository, we need to download the software in our local mission. Then you have to install that. Then only Docker will work. But if you try to install yum install Docker, this software is available. This software is available in these repo servers, but they are providing very old one. They are providing very old one. We are using community edition. The community edition is not available here. The community edition is not available here. If it is available, it is available. If it is available, yes, we can see the package name instead of no matching packages list. So it's mean the package is not available. Package is not available. Now what we have to do, we need to install community edition. If you want to install community edition, Docker organization providing community edition software and enterprise also. But enterprise product is complete licensed product. We are using community edition. Okay, so both are same. Community edition and Docker enterprise and both also same. Okay, but now we are using free of cost software that's calling as a community edition software. If you want to install that software here, what we have to do is, first of all, they are providing one repo link. They are providing one repo link. First of all, you need to download that link from Docker Hub to Docker software to your local machine. Docker software to your local machine. Then if you apply the command, what is the command? M install docker -ce space -y. Then the command, this command, first of all, it goes to this local repository, whatever we have downloaded Docker repo. Then already inside this repo file, one text file is there. Inside the text file that's related to docker -ce. Inside that file, there is a link related to Docker where it's located, where the software is located. The software link is available inside this file. So now this command, first of all, it goes to local repo file. Then the local repo file calls to DevOps software. Sorry, Docker software. Now the software will download and install in our local machine. You got it? This is the procedure. This is the process to install. Not only this Docker, whenever you are going to installing or whenever you are going to listing, if the package is not available, maybe that the package is external repo software, third party software. First of all, you have to download their repo file, then you have to install that software. You got it now? Ansible also, Ansible it's available. Even Jenkins also, you need to download the repo file. Then you have to install install Jenkins. Okay, so like that. So if you are going to installing Tomcat, Jenkins and Tomcat, first of all, what you have to do, you need to install Tomcat, then you have to download Jenkins.war file from the Jenkins repository. I mean that Jenkins software console. From their server, we need to download, then we have to place into the web apps folder, then we need to start the Tomcat service. Okay, both are same like that. So externally we need to download the software. Okay, now so first of all, what we have to do, we need to create the link, download the link, repo link, then we need to install Docker. Now let me show you. Okay, yes, this is the our website. Here already I have mentioned that links to download and install software. Okay, click on that Docker. Click on that Docker installation. Now you can go to, guys, don't try to install this one. If you install this one, you will get very old version. Okay, even the some issue, you will get some deprecated, and you will not get some advanced commands also, latest commands. Okay, not available inside that. So that region. Okay, so this one for Docker Community Edition. So not only for CentOS, not only for CentOS 7. Okay, you can install CentOS 8, Rocky Linux 8, Alma Linux 8, Red Hat Linux 8, and 9 also. At present we are using 9.4. So you can use this one also for 9.4. Yes, now let me install this one. Now we are going to installing mutils, device map persistent data, and LVM2. LVM2 mean logical volume 2. Okay, yes. What happened? Okay, so there is so now guys, we have installed those packages. Now we are going to creating or downloading repo docker ce repo file. Okay, now copy this one. Yes, now you can list ll space dash etc m dot repos dot d. See guys, okay. Now vam slash etc m dot repos dot d docker hyphen ce. Here we don't have that m. Install vam duplicate tar hyphen y. Okay guys, so we have installed which packages? Yes, duplicate tar, this one. Now guys, okay, so m install docker hyphen ce space hyphen y. Now we are going to install it. Just wait guys, it's going to installing. If you haven't installed, yes guys, you also install the docker. Maybe some network issue. So what happened? Okay guys, successfully we have installed. Now guys, so once you install software, by default it won't start its service itself. It won't start service itself. We need to start the service by applying the command Yes, first of all, you can check the service is running or not. Yes, system system CTL status Docker. Don't apply CE for installation, for uninstallation. Okay, only apply the Docker CE. Okay, but for working with Docker, just you have to apply only Docker. Okay, so guys, the package or the service yet not started. So now what we have to do? We need to be started the service. Now system CTL start Docker. System CTL start Docker. Yes, it's started. Now you can check it once again. See guys, Docker service is started and active and running. Now, if you reboot this server, if you reboot this Docker engine or Docker server, OS server, Docker won't work once again. Okay, without starting once again, if you want to work with the Docker directly after rebooting, without starting Docker, if you want to work with the Docker after rebooting, so we need to enable that service, Docker service. System CTL enable Docker. From next reboot, automatically the Docker service will start automatically. You need not to start manually Docker. So sorry, system CTL start Docker like that. You got it now? Okay, guys. Now, okay. So Docker service started. Now we can work with the Docker software. So first of all, let me check with this Docker software if this software is working or not properly. So for that, okay, guys, keep in mind here every command having different categories. Sorry, here Docker commands are having different categories. One, image related, network related, Docker swarm related, Docker compose related, Docker container related. Like this, we are having commands. Docker service related, we are having commands. Okay, so here the structure, Docker structure. So first, how it works? Hey guys, or else just wait. Just wait, guys. See, guys, introduction to Docker. Docker is a container management service. The keywords of Docker: develop, ship, and run anywhere. We can develop, we can ship to anywhere, and you can run anywhere. Okay, the whole idea of Docker is for developers to easily develop applications, ship them into containers, which can then be deployed anywhere. Containers nothing but not a vehicle containers. Okay, don't feel like that. Okay, we'll see that. Next, guys, build, ship, and run. So features of Docker. Okay, Docker has the ability to reduce the size of development by providing a similar or smaller footprint of the operating system via containers. Okay, of course, it's 100% correct. Actually, what is the size of OS? Even if you want to download OS, if you want to download minimal OS, what is the size of OS? Yes, almost 1.4 GB, 1.4 GB or 1.2 GB. See guys, what is the size this one? 945 MB. Of course, when it was downloaded in 2021, okay, April. Next, coming to recently we have downloaded. See, what is the size? 1.57 GB. 1.57 GB. This is the minimal OS. Minimal OS. Next, Rocky Linux 1.48 GB. See guys, CentOS 973 MB. Minimal OS. CentOS 7. CentOS is not available right now. Okay. LTS software not available. CentOS LTS version is not available. Steamed version is available, but that's not suitable for our practice purpose. Okay. See guys, the size is 973 minimal OS. So whatever we are seeing the word here, it's 100% correct. Okay, reducing the size of the OS. Okay, next with the containers, I'll show you that what is the size of OS. CentOS will see the 231 MB. Which one we are going to downloading image? CentOS image template, the size is 231 MB. Okay, it's very small size OS. Once we download and once we create container, whatever you want to install, you can increase the size, but they are giving very less size of the OS. Okay, they are not providing all kinds of facilities. What are the necessary, what are the basic needs with working with the software OS? Those services only they are providing. You got it now. Next, see guys, with the containers it's become easier for okay, teams across different units such as development, QA and operations to work seamlessly across applications. Of course, this is also 100%, not 100,000% correct. Okay, next, you can deploy Docker containers anywhere. This is also 100%. Okay, on any physical and virtual missions, and even on the cloud also. Okay, even cloud also we can. Since Docker containers are pretty lightweight, they are very easily scalable. Okay, these are very good. Okay, 100% whatever they are saying, 100% these are correct. When you can understand, when you can see these advantages with the Docker, once you enter into the Docker, if you try to execute the commands, and whenever you are having that hardware and the software resources, I mean that if you have that good knowledge and experience working with this OS, and whenever you are having that strong experience or at least minimum basic experience with the hardware, those guys, everyone can understand. Whoever having that basic knowledge and experience working with hardware and operating systems, those guys understand easily about these concepts. Okay, it's very easy and lightweight to manage. Yes, where we can run, guys, I have developed this document in 2015 around. Okay, this one almost 9 years document, guys. This document is 9 years document. See guys, we can run on Mac, we can run on Linux, and we can run on Windows. Yes, Docker engine. Okay, next, Docker Hub, Docker Compose. These are the components. Okay, Docker engine, Docker Hub, Docker Compose components. Next, if you observe this one, see guys, of course, now this document is of course little bit old, but the concept is same. If you observe this one, see guys, left side one and right side one. What is the difference between first left side one and right side one? Yes. Sorry. More containers you can. What is a container? First of all, you need to understand about the container. Okay. See guys. Guys, are you there? Online guys.
Yes, sir.
Yes.
Yes, sir. Yes, sir.
What is the difference between left side one and right side one? Very natural example. Take one natural example. What is the example? Yes, now we are seeing on the road a number of containers are going with goods. Okay. Inside that container there is a material. Whatever we are seeing the container box, that is the protector or wrapper. దాన్ని వదిలేసే ఫస్ట్ బెస్ట్ న్యాచురల్ ఎగ్జాంపుల్. అది కూడా కాదు. టెంపరేచర్ అనేది ఎందుకు, కూలింగ్ ఎందుకు పెడతావు? ఫస్ట్ అది ఇంపార్టెంట్. ఐటమ్ ఈజ్ ద ఇంపార్టెంట్. గూడ్స్ మెటీరియల్ ఈజ్ ఇంపార్టెంట్. ఓకే. ఎస్, material is important. Okay, we need to transport the material from one place to another place without damaging, without losing. Okay, without losing our material, we need to transport from one place to another place. If you observe this one, yes, what is the use of container? If you put one material inside the container, if you lock it, will we lose our material? No, that is safe, that is in safe. But if you transport like this on the vehicle, see on the, what is this? Is bullock cart or any open top? Okay, goods. See, in the vehicle we are, okay, what happening? Yes, we are losing the material. See here, no security, no security, no protect to goods. If you this one, if you take this one, we are putting all material in one container. It's mean whenever you are going to executing one application with the container, Docker container, we can't lose. Okay, it will come with end to end. It will come with end to end without losing the material. You got it now? But if you open this one, if you go through this one, yes, we will be in the trouble. Okay, you got it now? So that reason, containers are very good and secure for transporting material or data. Same like that here also. Okay, so we are maintaining all libraries and binaries along with the packages. We are converting one template format, then we are shipping to another location, then we are going to pulling that once again, we are going to executing. Build, here we are seeing that build. Yes, if you want to build that is a template. Once you build the image, okay, once you build the image, it will convert into template. That template we are going to uploading into Docker Hub or any private or public registries. Wherever we are storing the images or templates, template nothing but image nothing but a template in Docker terminology. We are converting into image format that we are storing in one location, either public or private. For private purpose, yes, you can use Nexus repository or GitLab also. You can use store our templates, I mean that images. After storing, yes, you can ship. After converting into template, you can ship into anywhere. Now we have uploaded one image. What is it? Not only one image, yes, we are having n number of images. See, I have built the software and I have uploaded into, I mean that I shipped into locations. It's a world centralized repository. Wherever you go, yes, you can pull from here, you can execute. See, this all everyone can download this one. Everyone can download this one. You can execute this one. You can build, you can ship, you can run. Okay. See, this is the structure. Where is that one? Sorry. Yes. See guys, build, ship and run. See guys, without missing any single material item. Okay. This is the traditional. This is the okay. This is the traditional and this is the latest one technology, Dockerization, containerization technology. See guys, we are converting all in one container format, then we are loading and shipping. Coming to containerization technology and virtualization technology. See, it's a heavyweight one. Left side one, heavyweight one. Right side one is lightweight. No need guest OS. No need guest OS or a hypervisor or VM or something. No need. Directly you can install the Docker on host machine, then you can create containers. Okay. See, whenever I was designed this document for the time, they are saying must be Linux. Must be Linux. Of course, initially there is no Docker software for Windows platforms. Initially, in the beginning days, okay, there is no Docker software for Windows. Okay, after that they have developed for Windows. Now Windows also available. Okay, when I was designed this project, or I mean this document, for the time there is no Docker software for Windows. So that reason they have mentioned here must be Linux, but this is not correct right now. Okay, we can for Windows, we can for Linux also. Next, see guys, 2013, as for Babu, what is that? Okay guys, see guys, as for 2013 document details. Okay, but this analysis right now, this is not correct. Okay, don't take this one. Okay, but just I'm giving this information, what is a Docker, how it works. So where we can run. Okay, we can run on static websites, backgrounds. Okay, web front end, user DB also we can maintain, analytic DB also, API, and okay, we can everyone. See guys, wherever you go, that the matrix format, okay, help. These are the major challenges before Docker. Before Docker, okay, these are the major challenges for, okay, queues, analytic DB. We can't execute on all platforms. Okay, wherever you go, yes, we are getting all kinds of issues. Question mark means it's a problem. Now we can convert like this format. We can ship anywhere and on all platforms. See, is it correct or not? For we can ship that wherever you go. This is also, of course, this is one problem. We can resolve this one. By the container, we can transport all items. We can transport all items like this. See, now same like that here also. By the Docker container, we can execute on all platforms. This is the message. Okay, static websites we can, user DB also we can put in container. Yes, user front end data also we can put, and queues also we can put a data, whatever it may be, whatever you want. Yes, you can put into container. You can run anywhere. You can build. You can ship anywhere. Okay, guys, this is one major advantage with Docker. Next, coming to Docker, okay, eliminates. So what it eliminates? See guys, on also on local laptop also we can execute containers. Okay, and on the servers also, on data centers also. See, we can execute development VMs, QA server, single prod server. Okay, on on cluster, on-site cluster, public cloud, okay, contributors laptop, and customer services also. Wherever you go, yes, you can work with, okay, Docker. See guys, all kinds. Next, why developers care? As a developer, what they have to think, what they have to concentrate, okay, what they have to take important concepts, which kind of concepts they have to take as important concepts. As a developer, what they have to think while building the image. Developer nothing but who are going to developing the image. Developer nothing but who are going to developing the image. Those persons are calling developers. Okay. While developing the image, even if we are the developer, we need to concentrate based on user requirement. You got it now? If we take one example, mobile, laptop, or TV, or any material, which one you are going to buying? So while buying that, are we seeing or not? Are we testing or not? Are we seeing that requirement or not? Yes. What kind of features are there? So how we can operate? How long it will work? Okay. If we buy that, so what kind of issues will get? Okay. So what is the kind of support? Which kind of support they will give? For example, if you buy one laptop, if you will get one kind of issue. Okay. After getting that issue, what about that laptop? If no one are giving support, if the seller is not giving support to on product, what next? Yes, we need to go some other place. If the product is ready, we can work with. If the product is not working, so unnecessarily or complete we are losing our money, wasting money. Okay. So while developing the product, they have to think, depends on user requirements. For example, if we take one example, cinema. Okay. The director, what do you want to concentrate? He will think, he should think on audience opinion. Whatever he is going to writing content, writer, the content should reach to what is that? Audience. Okay, whatever the director is providing that directions in that movie, those directions should reach to audience. Then only the movie will hit, or else it will fut. Yes or no? So this is also very important. Wherever, even on physical devices or whatever it is, softwares also, even the softwares also. Okay, who are going to developing the software? 100% they have to concentrate on user requirement, user facilities. Okay, so like that here also, the importance of developing Docker images. Okay, see guys, build once, finally run anywhere. Once we build that image, finally we can run on anywhere. A clean, safe, hygienic, portable runtime environment for your app. Developer they have to think. Developer have to take care. Okay. Next, no worries about missing dependencies. Of course, don't miss, because it's a bundled. It's a bundled. Okay. No missing dependencies, packages, and other pain points during subsequent developments. Okay. Run each app in its own isolated container. This is one more big advantage with the containers. Okay, it should not depends on any other, okay, OS. It works independently. Okay, so you can run various versions of libraries and other dependencies of each app without worrying. Okay, next, automated testing, integration, packaging, anything you can do. Okay, you can script. Next, reduce, eliminate concerns about compatibility on different platforms, either your own or your customers. Of course, at present we are working on our own laptop for practicing purpose. For Docker practicing purpose, we are working on our own laptop. Once you get the job, Yes, you will work on company servers. You will work on company servers. The same concepts you can execute. Okay, like that here also. Okay, guys. But coming to, it's very cheap, zero penalty containers to deploy services, a VM without the overhead of VM. Okay, instant replay and reset of images, snapshots. Of course, it's very easy compared to virtualization technology. Okay, of course, even for learning also very easy. Learning also very easy. Okay, guys. Next, coming to why. Okay, it works. Okay, separation of concerns. See, guys, the container architecture. Of course, it's very. If I zoom it, uh, image will blur. Okay, guys. See, can okay. Then the developer worries about what's inside the container. Okay, imagine it. If you are the software developer, if you are the software developer, while developing that, we need to take care about the softwares. So what kind of features we need to put into that software? Okay, which feature in which place we need to be placed? Okay, which option will come, which after? Okay, guys, one after one, where we need to put. See, guys, okay, then the developer. So his code, his libraries, his packages, his apps, and his data. Okay, all Linux servers look the same. Okay, ask her the ops guy. Ops guy mean operations guy. Who are going to using this image? What they have to think? Worries about what's outside. Okay, the container. Next, logging, remote access, monitoring, networking configurations, all containers start, stop, copy, attach, migrate, etc. the same way. Okay, next coming to one more step. See, more technical details about why, what, run anywhere, run anything, high level, a lightweight VM, okay, low level, okay, CH root on, okay, steroids. Okay, guys, see, guys. Next, VM versus containers, how it works. It's a heavyweight, it's a lightweight. Okay. Next, one more upcoming. See, guys, already I have given some explanation on this one. See, this is the first app, original app, copy app, copy of app. You can copy that, you can remove whatever you want. Yesterday I told that, na, you can take one image. Okay, just imagine it. I am giving one image with Java, Git, Maven, Tomcat, and Nexus, Docker, Ansible, Kubernetes, everything I have installed inside that container. You can take that image. You can create container. Whatever you want, yes, you can remove that. Okay, whatever you want, yes, you can work with whatever you want to work with services. You can work whatever you don't want to work with services. You can remove that. You can create one more new image from your existed container. See, we can remove modified app. Okay, we can design like that. Next, one more. This is the structure of, you have to keep in brain. For this image only I have opened this document. See, guys, it gives us clear picture. See, source code repository, a Docker file. By the Docker file, we are going to building a image. We are going to image by the Docker engine. Host one mean, for example, just imagine it. I am one person. Okay, in my laptop I have installed a Docker and I have prepared one Docker file. I built one image. Then I'm converting into and uploading into Docker registry. One person. As a user, already I told that now, see, these all are my images. Not only these images, see, all are the images. These all are the images. Now you can download. I didn't develop this image. I didn't develop this image. Someone have developed this one. If I want to work with, yes, I can develop. Sorry, I can download and I can run that. Someone have developed, someone is using the image. Okay, like that here also. See guys, host 2, user 2. One user has developed one image and he pushed it into Docker registry. Docker registry. Then the user 2 pulling that image and running that. First he is searching the image. He requesting one command to search the image in the Docker hub. Then he pulling the image. Then he running the image with the help of Docker. With the help of Docker he is searching. With the help of Docker he pulling the image. With the help of Docker he is creating a container. Container A, B, C, D, like that. How many containers? Yes, you can create. These containers are calling as a active VM instance. Okay, executable server. Okay guys, but images are two types. Images are two types. One is plain image. One is the plain image and another one is custom image. Custom image mean? Custom image mean? For example, see guys. So this is one image, plain image. For best example, newspaper or textbooks. Newspapers are textbooks. If you buy one textbook, is there any chance to write your own data? Can we write our own data on textbook? Or else can you buy one newspaper? Can you write your data on newspaper? Of course, you can write on empty places. It's already predefined. Already it's a developed text. It's already developed text on the paper. You can't write. You can't write. Of course, if you write anything inside that paper, that belongs to you only, not belongs to all readers. You got it now? It's a custom. The newspaper holder, I mean that who's that organizer, newspaper organizer, publisher, whatever they are having feelings and expressions, they are going to publishing via text or via video or audio. Yes or no? All news channels and all newspapers like that only. Whatever they want to express, they are expressing in the text format, an audio format, or video format. If you are seeing one news channel, is there any chance to talk with them? Can you read your news? You are also having feelings. We are also having our own feelings and experience or expressions, but we can't share with them. We can't publish our opinions with them. Yes or no? It's a customed. Okay. Same like that. Newspapers and textbooks and like that. Coming to plain. See guys, here now I am giving one plain paper. Now is there any chance to write or not? Is there any chance to write or not? Yes, we can express whatever we are having, our feelings and opinions. Yes or no? Yes, I am giving one paper. Yes, write your opinion about my class. Yes, you are writing, you are giving that. Once I receive that, whatever you have given, that's your custom. That is your custom. That not belongs to any other one. Maybe that, okay, that custom information should not match to other one. Not equals to other one. Got it now? It's mean that's only your purpose you have developed. That's only you have developed your purpose only. Now, here whatever I have developed the images, Here whatever we have developed the images, these all images belongs to me. These all are my custom images. These all are my custom images. Already I have written some my opinions. Okay, I have expressed my opinions and my feelings inside that. Okay, that is only for my purpose. That is my purpose only. If it is required for you, yes, you can use that. Okay, you can use that. You got it on my point. But it's already finished product. It's already finished product. Based on my requirement, I have developed that. Okay, guys. If it is required to you, yes, you can use that. If it is required to you, yes, you can use also. Okay. That is the custom image. Custom image are predefined image or template. Image or template. Coming to here, plain one. Docker providing plain images also. Plain images also. Plain image nothing but, for example, CentOS image. For example, CentOS Ubuntu images. What they are providing? They are providing only OS. They are not providing any kind of other applications. You got it now? They are providing only OS like this plain paper. Whatever the necessaries are required, they are providing only those necessaries only. Next, whatever you want to develop, yes, create your own container by the plain image. Yes, now you can write whatever you want. Whatever you want. Okay, just let me show you for one example. One practical example. Okay, see guys. Here, first of all, just now I have installed Docker. Just now we have installed Docker. Now let me show you is this Docker working or not properly. Keep in mind, if whenever you want to work with Docker, Docker should have some images. Docker should have one image. See guys, now I'm testing. This is my local machine. I have installed Docker in my machine. Docker local engine and registry. Registry for storing the images. Guys, keep in mind. Registry nothing but storing images. Engine for executing the Docker commands. Docker engine for executing the Docker commands. You got it now? Docker registry for storing the images. Okay. For executing images, for executing containers, not only these two, to execute all related Docker services, we should have that Docker engine. With the help of Docker, we are going to working with images, containers, networking and all. See guys, now this is the Docker Hub. Okay, yes, now we are the beginner or we are the kid in Docker terminology and Docker technology. Okay guys, imagine it. Just now we have installed Docker. If you don't know how to work with the Docker, it means you are a kid in the Docker terminology, in the Docker technology. Of course, okay, we are the kids. We don't know how to develop our own image. Coming to this point, here, you don't know how to develop a Docker image by using Docker file. You don't know how to write a Docker file. Here, now we are acting as a host 2. Here, we are acting as a host 2. We are not acting as a host 1. Here, host 1 is the developer. Host 1 is the developer to develop the images. Here, host 2 is the user to use existed images. Okay, now we are acting as a host 2 because we don't know how to develop, how to write Docker files, and we don't know how to develop Docker images. Okay, guys. So, still now we don't have any kind of knowledge and experience working with the Docker files and the Docker imaging buildings. Now we are starting with Docker containers. We are trying to learn what is image, how we can get the image, how we can run the image, how we can create a container. See, forget about the development part, forget about image development. Now we are concentrating on get the image from remote to local, creating a container, working with the container. That's it here. You got it on my point. Now guys, now see guys, this is the Docker Hub. Inside this Docker Hub, okay, we are having containers, sorry, images. Here we are having images. Now, just now guys, I have installed Docker. Just now I have installed Docker in my machine. I want to check with this Docker, is it working or not properly? Okay, I can't certify myself. Okay, I can't certify myself. Yes, this Docker is working fine. Okay, so that reason, Docker providing one image, to test our Docker local engine is working or not properly. You got it now, guys? To test is our Docker engine is working or not properly. Okay, so now the image is hello world. Image is hello world. You need to pull and run in our local machine. You need to get the image from remote to local, then you need to run that image. Okay, once you run that image, yes, we will get one container, temporary container. Yes, it will run the container and it will display some content and simply it will kill itself. Okay, whatever we got the content or message from the Docker container, that message gives us, if our Docker engine is working properly, yes, we will get, yes, your Docker service or Docker installation is correct. Okay guys, and here keep in mind, whenever you want to get the images from remote to local, we should have internet. Not only lightweight, okay, not only internet connection, and you should have that limit also. Okay, these images are having 1 GB, 2 GB, okay, like that, hundreds of MB, okay, like that. Whenever you are going to downloading that image, it will consume that much of size data. Okay, it will consume that size of data to get the image from remote to local. At the same time, whenever you want to send the image from local to remote, that time also you should have internet and data limit also. You got it, guys? Now let me download from remote to local. Guys, here we are having commands, different commands to work with Docker. Okay, see guys, already I shown that in a Docker file. See guys, this is one Docker file and this is also one Docker file. Okay, like that we are having different Docker files. See guys, this is also one Docker file. Like that we need to develop this kind of text, then we need to develop image by using this text. We will see that slowly, we will see that, but this is not right time to discuss about these Docker files. Let me show you, okay, first how to pull the image and how to run the container. Okay guys, now here I am saving this document. Okay guys, so first of all, what we have to do, we need to install the Docker. After installing or before installing Docker, yes, rpm space hyphen docker hyphen c for what? To check either Docker software is installed or not. To check software or not. Okay, see guys, of course already we have installed. We will get that answer. See guys, sorry, rpm space hyphen qi Docker hyphen ce. See guys, this is the message from Docker and official message from the Docker. Whatever they have given, what is the Docker? Okay. Next guys. So now it's working fine. Now Docker images. If you want to see about a Docker guys, yes, Docker info, sorry, Docker version, Docker hyphen version, next to Docker info. Okay, we will get here, we will get the Docker information, how many containers are there, how many images are there, how many running, how many paused, how many exited, and how many images are there. Next, we will get the operating system where we have installed Docker. About that host mission, we will get okay, which OS we are using, is it 32-bit or 64-bit, and whatever we have given, processor and RAM. Okay, operating system name and host name also we will get, and some other information we will get, that Docker Swarm, Docker, what is that, Docker Compose, we'll get this kind of information. Here we are having Docker server and Docker user. We are having Docker user and Docker server, both information we are having that. Okay guys. Next, Docker, by the Docker info we will get lot of information. By the Docker version we will get client information and user information and version and all. And just Docker hyphen version command, we will get only either package installed or not, which version we have installed. Okay, now let me show you guys. Yes, Docker hyphen version, single line message we will get. See guys, Docker version we have installed 27.0.3 build. Same command, Docker hyphen version. Just if you apply that hyphen, you will get, sorry, remove this one. Sorry, remove this one. See guys, here we will get client nothing but user and server information. See guys, if you apply the Docker info command, you will get much more information than these two commands. Okay, next, Docker info. But for running this time, for executing Docker version and Docker info, before applying that command, you should start the Docker service. Otherwise, you will not get Docker server information. Client information you will get. Without starting Docker service, you will get a client information. But you can't get the Docker server information without starting Docker service. Okay. So whenever you are getting Docker server information, it means already you have started Docker service. Okay guys, see guys, huge information about server side. Okay, server version, images, number of images, stopped, paused, running, total containers. See guys, and operating system name, kernel version, type, architecture, CPUs, number of CPUs given, and RAM how much we have given. See guys, okay, IP address, everything we will get by the Docker info command. Okay guys, that's all. Now, okay guys, just wait. Okay guys, so just what we did, we have installed Docker and we need to run the command to test is this Docker is running or not properly. Docker service is running or not properly. Yes guys, so here for these are the command to check Docker version, and this is the command to see the Docker is installed or not in our local machine, and this is the command to list all existed images in our local Docker registry or Docker local machine. Next guys, Docker search, this is the command, this command used for to search the desired image just for the desired image in in Docker Hub. Docker Hub. Next, Docker pull is command used for to get the image from Docker Hub to local Docker registry. Local Docker registry. 1 minute, guys. Local Docker registry. Next, guys, Docker run. Docker run. This command used for to run the to used for to create a container. Okay, guys. Yes. Here, for example, here we are having syntaxes and examples. Yes. For some commands, we are not having examples. For some commands, we are not having syntaxes. Okay. We are having direct examples on this. Okay. Now here we don't have a syntax. Here we are having example only. Yes. Let me show you guys. So first of all, let me set host name here. Host name is sorry. Host name ctl set icon host name. Yes, Docker exec batch host name. See guys. Now we set the name. Next, Docker. What is the command? There are Docker images. See guys. Okay. This is the command. At present, we don't have any single image because just now we have installed Docker. So that reason, here we don't have images. Okay. Yes. Next, guys. Now, we are going to searching the image to see or to test is this Docker registry local Docker software host mission is working or not properly. For testing, our local Docker host mission is working or not properly. For testing purpose, we are pulling this image from the Docker Hub to local machine. Before that, we are searching the image. Before that, as a host 2. Now I am imagine it. I am the host 2 person, not a host 1. Your host 1 is the developer. Host 2 is the user. Okay. Now I am applying the search command to get the image local. Sorry, what is that? Hello world image. To get the image from Docker Hub to local machine, I am searching is that image is available or not. Now let me see that, guys. Yes, Docker search. Here we are having syntax. Yes, Docker search image name. Image name. Okay, guys. Next. Okay. Yes, guys. Docker search image. What is that? Hello world. This is the example. See, guys. Here we are having hello world image. Just I'm taking few images only. Here we are having that, guys. Okay. See, guys, This is the official image. Now this is the syntax and example. Okay. Now next another one, Docker pull. Here also we are having syntax. Syntax. Docker pull image. Docker pull image name. Yes, guys. Now example. Yes, Docker pull hello world. Guys. Yes, we got the image. Output. Docker images. See, guys. After getting the image, yes, we are seeing the image. Now, okay, Docker run command. Docker run command. This command is used for creating a container. Now we are testing with this hello world image. With this hello world image, we are testing is this Docker software working or not properly. Okay, yes, Docker images. Guys, next here Docker ps Docker ps. This command used for to list running all running and paused containers. All running and paused containers. Yes, let me apply that. See, guys, Docker ps. Here we don't have any kind of image. Sorry, any running container. Any running container. This is the output. Here we don't have syntax. Example. Here we don't have. Next, Docker ps -a. This command is used for to list all running paused and exited containers. Okay, yes, Docker ps -a. See, guys, here also we don't have any container, either paused container or exited container or running container. Okay, this is example. Here also we don't have syntax. Okay, next coming to Docker run. Docker run. Docker run command. This command is used for to create a container. Now we are going to first container. We are going to creating first container. That container also for testing our local Docker engine is working or not properly. For testing purpose, we are going to creating. Next, first of all, let me list all existing images. Docker images. Okay, now Docker run -it. Docker run -it. Hello world. Hello world. See, guys, this is the command. By this message, we can understand our Docker engine are Docker working correctly. This is the official message from the Docker. Official message from the Docker. Okay. Now guys, after a successfully we have tested whatever we have installed Docker, whatever we have installed Docker in fine. Now we are starting with the containers, our custom containers. Okay, testing part is over. Okay, and whatever we are having commands here, Docker images, Docker ps, Docker ps-a, Docker search, Docker pull, these commands we can use for our custom containers creation, custom image creation, custom image pulling also. Okay, for searching also we can use commands. Now guys, task over. Now here docker run. Docker run is a command, that command used for creating a container. Creating a container. Okay guys. Yes. This command used for to create a new container. Create a new container. Okay. Yes. Syntax 1. Here we are having plenty of syntaxes. Syntax 1. Yes. Docker run -it for initiate, initializing, initiating the container. Okay guys. Next, Docker run -it image name space command. Image name command. Next, example. Here, Docker run -it hello world. So first of all, remove this one. Yes, hello world. Here we are testing is our Docker working or not properly. Okay. By running this command, by executing this command, Docker run -it. Don't forget this one. So even my side also, that's a mistake. Okay, mistake is mistake. Okay, Docker run -it hello world image for testing the image. Here just we have applied the command. So here note by above command, okay, container will create and kill or stop itself itself. Okay guys, automatically it will kill or it will stop itself after executing above message. What is the message? This is the message. By the above command, container will create and kill or stop itself after executing the above message. So it's mean container is there. Container is there. What is the command to list existing containers? What is the command to list existing containers? guys? Sorry. Yes, existed containers, not exited. In existed, Docker PS hyphen A. Exited is different, existed is different. In existed containers, how many types of containers are there? Three. One running, paused, and exited. Okay. Yes, guys. Now, see here, Docker PS hyphen A. The container is there and exited. Okay. Itself automatically it will kill. Next, now Docker RM. Docker RM. I'm going to deleting that container. Now I'm going to deleting that container. Which one we have created? Yes. This command used for to delete exited container. Exited container. To delete exited container. Okay, guys. Guys, note here. So still we are in syntax 1. In Docker run command, still we are in syntax 1. Okay. Next, Docker rm command. This command used for to delete exited container. Exited container. Okay. So exited mean already it's existed. You need to understand. Okay. Whenever you are going to deleting a container, it's mean we need to decide already one container is there. The container is already existed one, and you need to make sure that if the container is available or not before deleting that container. Okay. So in my case, I already have the container. See, Docker PS hyphen A, that is exited. It's exited. Now, okay, yes, syntax Docker RM container ID or container name. Okay. Yes. Note. Make sure is the container okay exited or not. Okay. Make sure the container is exited or not existed, even existed and exited. Existed and exited. We should have container and the container should be in exited state. We should have container and the container should be in exited state. Okay, then only above the command will work. Otherwise, you will get another different answer. Okay, see guys. Now, this is the syntax and example. Okay, yes. Docker RM container ID or container name. I am taking this container name. Okay, yes, guys. See, guys, successfully we have deleted. Now Docker PS hyphen A. No more container. Okay, so we have deleted successfully. We have deleted. Take this one. This is the example. Yes. Here we have deleted. Now at present, no more containers. We don't have any single container. Now let me create our next one more Docker run syntax 2. Syntax 1. Yes. Now Docker run -it -it space image name space command. Okay, so here command means command nothing but you need to apply any one command, either shell or bash or something that you need to give that. Okay guys, now syntax, already this is the syntax now. Yes, now example Docker run -it space CentOS /bin /bin/bash. Here, okay, CentOS is the one OS, one plain OS image or template. Image plain OS. Okay. Next, /bin/bash is the shell command. Shell command. Okay, guys. Not. Okay. By -it. By -it. Okay. Container will create. Container will create and okay. Cursor moves into container. Immediately cursor moves into container. Into container. Okay. Guys. Now the cursor. Now where is the cursor? If we run this command, okay, container will create. Immediately the cursor moves into container. Here we need to understand. Okay, mostly cursor in two places. Should be in the two places. Okay, in one, in the local machine. In this local machine, two parts are there. One, guys, this is the OS part. This is OS part. So here we are having host mission, libs and binaries. Host mission, libraries and binaries. Next, another part is Docker. Another part is Docker. Okay, guys, keep in mind. Another part is Docker part. So inside this Docker, here we are having images. Here we are having images and containers. images and container. Here we are having images and containers. Image nothing but a template. Already we have discussed. Okay. So guys, if we are having containers, every container should depends on any one image. Okay. The container, if we are having container, the container should have image. Without image, we can't create a container. Okay. Container. Inside this Docker environment, yes, we are having container. See guys, now where is the cursor? Now where is the cursor? Now the cursor is inside the container. Now the cursor is inside container. You got it now? Now whenever you are inside the container, automatically cursor moves into container. Guys, keep in mind, container also a OS. Container also a OS mission. It is also instance. It is also one server. Okay, it is also one VM. Keep in mind, you need to digest this one. Okay, so now inside this, now the cursor is inside this OS, container OS. Whenever you want to come out from the container, there are two commands. Yes, if you want to come back to Docker host mission, guys, keep in mind, Docker host mission nothing but wherever we have installed, on which mission we have installed a Docker, that mission calling as a Docker host mission. Wherever we have installed a Docker, that one calling as a Docker host mission. Okay. Now guys, keep in mind. Next. Okay. This one. It's a container. Already we have created container. And we have removed that container. Now at present we don't have any container. Now what we are doing that? Now from the Docker hub, we are going to pulling one more image, that is calling as a CentOS. Now we are pulling the image from our Docker hub to our local Docker engine. Imagine it. It's a CentOS. CentOS image. We are pulling that image with the help of Docker engine, or Docker software. We are pulling that. Image. Once we pull that image, it comes into Docker registry, local Docker registry. So first of all, check that image is available or not in our local Docker registry. What is the command? Docker images. The command always Docker images. Guys, keep in mind this Docker images command, it works only in our local Docker registry. Okay guys, this command works only in our local Docker registry. Now what I am doing that? Now I am going to pulling the image from Docker hub to our local mission. Yes, again Docker pull image name CentOS. See guys, already we have written the command Docker pull command. See, here we are taking one more example. See, now it's going to pulling the image. Yes. Final result. After pulling. Okay, guys. Okay. Next. Docker images. Docker images. After pulling the image, Docker images. See guys, we got one more image. Hello world and CentOS image. Now, this CentOS image is in our local registry. This CentOS image is in our local registry. So, what is the image? Image is a template. It's a predefined, structured or predefined instructed steps. We have given some instructions. Okay, I didn't given that instructions. Whoever have developed that image. Okay, those developers. Okay, those guys have given some instructions to work on client location. I am the client here. I am the host to person. Host to mean user. Okay, based on my requirement, they have given or they have developed that image. Okay, not only for me. Who are going to downloading that CentOS plain image? Everyone will get same output. Whatever we are getting output right now, the same output will get throughout world that Docker image users. Okay, but this CentOS image is a plain OS image, nothing inside. Just they have given only basic level operating system. Basic operating system they have given. Okay, after pulling this image, you can create one container. You can create a container. So once you create a container, you will get same plain OS image. For example, see guys, this is one plain OS image. This is image. If you run a container or if you create a container, we will get one container with plain CentOS container. What is the difference between container and image? Image is a blueprint or instructed or pre-constructed with instructions, set of instructions. Pre-developed, it's a developed setup with a set of instructions. Okay, whatever they have given the instructions, those instructions only will work in the container. It's a active container. Container nothing but a instance or VM. Okay, so it's a OS, and this container will work isolatedly with other containers or other systems. Okay guys, it is also a OS. It is also a OS operating system software server. Okay guys, now guys, so whatever we are having instructions here, the same instructions comes into this container. But here we can't work with those instructions. We can't implement those instructions here in the image or in the image format or in the template format. We can't. Once create a container with the help of this image, then we can implement or we can work with those instructions whatever they have written inside the template. Okay guys, now let me create and note that point here. One more guys, just imagine it, while creating a container while creating a container, if you don't have image, okay, for creating a container, okay, whenever you are going to creating a container, for the time if you don't have an image, okay, if you try to create a container without having image in our local machine, okay, for the time if you don't have internet, you can't create. You got it now? Guys, I'm repeating it once again. Whenever you are going to creating a container, okay, for the time if you don't have image in your local machine, in your local machine, you don't have image in your local machine, but you are having internet, yes, you can create. You got it now my point? Whenever you are trying to creating a container, for the time if the image is not available in your local machine, for the time if your machine is connected to internet, yes, by that container we can create a container. By doing that command, by applying that command, the command it will do two actions. First of all, it will pull the image from remote to local, then it will create container. You got it now? Okay, I am repeating once again. Whenever you are going to creating a container, for the time if the image is not available in our local machine, for the time that if the machine is connected to internet, yes, by that internet we are pulling the image, then immediately the command will create container. It means the command it will do two actions. One, it will pull the image first, then it will create a container. Whenever you are going to creating a container, for the time if the image is not available, for the same time if the machine is not connected to internet, command will fail, because image is not available in local machine. At the same time there is no chance to get the image from remote to local. You got it now my point? See, now in my case I have already CentOS image, but I don't have Ubuntu image. You got it now? I don't have image. Or else let me create one container with the Tomcat. Docker run -itd. Yes, here syntax 2. Again, syntax 3. Okay, here what I am doing, I am going to creating a Tomcat container. At present, I don't have Tomcat image. I don't have Tomcat image here. Now you can check it. Docker images. Here I don't have, but my machine is connected to internet for testing. M update -y. If any updates are there, yes, we can update. If it executing, see guys, nothing to do, complete. It's mean if we don't have internet, immediately it will get that mirror not found, mirror list not found. You got it now? So it's connected to internet and it tested or it checked to remote repository. Both are same. My local machine and the remote repository both are having same packages. Okay. Now guys, it's mean my server is connected to internet. Now what I am doing? Docker run -itd, Docker run -itd, image name and command. Okay, by above command we are creating a container and running in backend or detach mode. Okay, it's me. Cursor should not move into container. See the command here, docker run -it. By this command, what it will do that? The Docker will create a container and immediately cursor sends into inside the container. Docker will create a container and immediately the Docker sends to cursor to container's location. You got it now? Container will create, immediately the cursor comes into the container inside the container. So it's mean already I told that now we can see only in one location the container, either inside the container or outside the container. Outside the container. Yes, we can come out from the container. We can come out from the container in two ways. One is graceful, one is forceful. Okay, guys. If you come forcefully, container will kill. Okay. Exit. Okay. If you apply the exit command, so what it will do that? It will kill the container and the container comes into, cursor comes into the Docker host machine. Okay. Now, at present, we don't have containers. Let me show you that concept is pending. Practically, that is a pending. Okay. Now, so what we are doing here? So by this command, what it will do that? See guys, now the cursor is here. Now we are going to creating a container with the help of any one image. Immediately container will create, Docker will create the container and immediately cursor comes into the container. Only one place we can see container. We are having only one cursor. We are having only one cursor. We can see in only one location, either in the host machine or in the container. Once the cursor is inside the container, we can't work with the Docker host machine. And we can't work with the Docker commands also, because the cursor is inside. When we can execute the commands, Docker commands and the Docker host machine commands, you have to come out from the container. You have to come out from the container. So now this concept is pending. Just wait. Now what we are doing? Now first let me create this container. Okay, let me create this container. Okay, Docker run -itd image name command. See guys, not itd, only -it. Okay, now let me create one CentOS image or else one Docker image. Ubuntu image. Okay, na Docker images are present here. I don't have that image. At present, I don't have image. Now I am trying to create one Ubuntu container. Already I told that now without image there is no container. Fix it. Without image there is no container, but there is an image without container also. Without container we can store the image, but if you want to create a container you should have image. Without image there is no container. It's a fix. Okay, wherever you go. Okay, now at present I don't have that image and Ubuntu image, so no more chances or no chance to see container. Docker ps. Okay, now docker run -it ubuntu /bin/bash. This is the command. See guys, unable to find image ubuntu latest locally. It's okay, it's given message. It is tested. It is searched in the local machine, but there is no image locally. See. Now this machine connected to internet, so that reason now it's pulling the image. It's pulling the image, then immediately once pull the image, pulling is over, then it will create the container. See guys, container created and the cursor comes into the, now the cursor inside the container. You got it now? See. Okay. What is the command to know operating system name? cat /etc os-release. See, operating system name Ubuntu. Latest one Ubuntu LTS name. Okay, LTS. Next, see guys, like ID Debian. See, now the cursor is inside container. Where is the cursor? Inside this container. Now what I am doing? Now I am coming out from this container. Okay. See, I think already I have given explanation. Just wait. See guys, Docker kill, or Docker stop. Okay, Docker kill or Docker stop. By this command, exit command, by exit command, where inside the container. If you execute or if you apply the exit command inside the container, the command what it will do that? Yes, it will kill or it will stop the container. Now the cursor is inside. Now the cursor is inside this container. Now if you apply the command, now if you apply the command exit, what it will do that? This command it will do that, it will stop the container. The command stops the container and immediately cursor comes into the Docker host mission. So finally this container no more in running state. No more in running state. Okay, where is the container now? What is the container state? Stopped state. Whenever you apply the exit command inside the container in running container. Okay, whenever you are going to applying the exit command in running container, so the command it will do stop or kill the container. Once the container will kill, die, what will happen? It comes into the stopped state. Okay, now you can see guys. Now where is the cursor? Now the cursor inside container. Now I am applying that exit. Okay, now you can see that. Already I told that now. Docker ps space -a. This command used for to see the all running and paused exited containers. Now see guys, exited. Okay. Now one more command we are having. I am going to creating one more container. I have created. Now the cursor is inside container. At present I have total 2 containers. One is in running state, one is in exited state. Now okay, another container. This one gone. Another container. Now the cursor is inside this container. Now okay, now if you apply the command, here, what is the command? ctrl plus p plus q. ctrl p plus q. So what it will do? This shortcut command will do. Okay, it will do the command. What it will do? The cursor come out from the. It perform the action to put the command inside the host mission. It means the command, the control plus q command, it will do the action to run the container in detach mode. Detach means backend. Okay, whenever the container is running in detach mode, for the time the cursor is not inside that container. Which container is running in detach mode? Okay, those all containers are not having cursor inside that containers. Okay, backend those containers are running. Okay, in which container is cursor is there? That is the attached container. You got it now? Whenever we are seeing a cursor inside the container, that container calling as a attached container. You got it now? whenever you are seeing the container outside the container, but container is running, that containers, which containers are running outside the cursor, outside the cursor, it means those containers are detached containers or backend running containers. You got it now? Now, if you want to put this, if you want to put this container in detached mode or in backend, okay, yes, you have to apply control PQ. Now you can see Docker PS, only one container is running. We didn't apply the command exit. We have applied the control plus P plus Q. Control, hold the control, press the control and hold the control until pressing PQ. Okay, control PQ. Okay, don't leave the cursor. Sorry, control until pressing Q. Control P Q. Then what are the Docker will do? Docker will do it will perform the task. Wherever the cursor is inside the container, the cursor come out from the container and immediately the container moves to in backend mode, in detached mode, but it won't stop. It won't stop. This is the, now you can see that Docker PS-A, one is in exited state, one is in running state. Which one is in exited state? Okay, that time we have applied the command exit inside the container. Okay guys, this is the process. So guys, here we are stopping today. We will continue from here tomorrow. Okay guys? Yes guys, any doubt here? Yes, any doubt guys? No doubt?
No, sir.
Okay, okay.